Hello, my name is Alex Dummett. It's very nice to be here. We're going to be talking about prompt engineering for healthcare. So I am a former associate program director for internal medicine residency, as well as a quality improvement and patient safety fellowship. And I'm very interested in artificial intelligence and have been using it in my practice for over a decade now. First, predictive analytics, and for the past 3 or 4 years now, generative AI. And I have a deep interest and passion in patient safety and quality improvement after completing a fellowship many decades ago. Um, so to begin, I do have some disclosures. I used many artificial intelligence tools in order to make this talk and edit it and evaluate it. And I'm working for quite a few companies as a consultant. And I'm practicing as a telemedicine doctor. And I was formerly with Kaiser Permanente for 17 years until this past March, where I have very fond memories working with them. And now I'm here in Tampa, Florida. Let's begin. We live in three different epochs of artificial intelligence. At first, it followed directions and coded rules, if-then statements. It could do it okay. Then we got into deep learning, where it used lots of different information in order to make decisions and figure out and group things. Like, is it a cat? Is it a dog? Now we're in generative AI, where it can generate content, text, sounds, and images, and movies. So generative AI is a form of artificial intelligence that creates new content by looking at patterns and structured data. Large language models, and there's thousands of them now, are models that can efficiently understand and summarize and generate and predict the next word. And if you think about it, computers are written in binary, zeros and ones. So this is hello, my name is in binary, or hello world, actually. And these words and letters and numbers are then structured as tokens. And these tokens are shown to have meaning. And that meaning can actually be described as a number or a weight. So, for example, this is from a wonderful talk out of Stanford, just came out a few days ago. A patient has multiple codings of their of different concepts built into it. And these are 5 numbers, but in reality, it has many more than that. So what do the codings do? The codings can point it in a direction, in a vector. So the vector is king to queen, man to woman. The direction of that vector, somewhere in that line in between those two numbers, is gender. Okay? So this is 3-dimensional. It has many more dimensions. And if you think it was actually this dimension for patient, it's actually this for ChatGPT 3. This is over 12,000 defined codings of the patient. So imagine having all of these tokens that can predict the next token based on the relationship to the next word. And in that odd, weird prediction, it actually shows something that approximates knowledge. And it's rapidly exponentially increasing. So the more information we put in, the more test time compute, the more fine-tuning, the more training that we do, it gets smarter and smarter and smarter. And we're now able to answer 96% accuracy on USMLE test, which is the test to become a doctor. It has been shown repeatedly that these tools are getting better and better over time and are as good or better than many of the doctors. That's what these two graphs show. So what is a prompt? A prompt is a phrase or a sentence or a paragraph or instructions or code that you initiate a conversation with a large language model. And prompt engineering is the process by which you practice to improve the quality of the outputs based on better and better prompts. There's lots of different ways in order to prompt. There's lots of different tricks and patterns. Oddly, the smarter the model, the less deterministic or precise you need to be in your prompt, because it'll actually question you or it'll infer what you're saying. But it is still very important to know how to ask questions in a certain way. So right now you think prompt engineering may look like this, a whole bunch of ones. I don't know how to get in and get out what I really want to. Hopefully by the end of this talk, you'll feel that prompt engineering looks more like this. It used to be the hot skill, $300,000 a year payment to these prompt engineers, English majors who could speak to this and different tools and get very different outcomes. Now everybody without a doubt, everyone who's doing some sort of knowledge work will have to know how to prompt. There's many different terms. The only one I'm going to mention on this crazy page is RAG. If you're using it for something that is meaningful, you need to have it grounded in some sort of truth. And how do you do that? You'd use RAG, or retrieval augmented generation. It can be graph RAG, it can be embeddings, it can be a lot of different ways, but you need to have it reference material and show where it got the information from, because encoded in those numbers is a approximation of what the actual reality is, and it includes biases and omissions and confabulations. So you need to often have it reference something of reality when it's actually giving you an answer to use it effectively and safely. And then there's a whole new world of agentic flow where prompts and agents and LLMs talk to other LLMs and they complete a task at higher quality. So what I've done, you guys can click on this, you can go through different prompts and how I've set them up. So there's just a few of these. I have hundreds and hundreds of them, but they're just examples of how I set them up. And I'm going to show you what I did in order to set them up. So first of all, there's many different models. There's thousands of models. I think maybe about a year or two ago, there were 45,000 models that you could download and install into your own computer. So here's the tool that the process that I use. Very simply, I set a user or persona. So you're a professional chef, recipe developer, and you're going to create a full recipe for a specific dish, list the ingredients clearly, provide step-by-step instructions, format the output with ingredients and instructions. Here's an example of an output that I want you to do for a chicken salad. And think step by step, making sure to combine all the seasonings, prep, etc. You are a chef, make an ingredient list and instructions. So another tool that I use delimiters. These delimiters are brackets, curly brackets, stars, lines, underscores, hashtags. They're really helpful to break up the prompt with those different pieces. So I use this one. Every single time I do it, I start off this way. So I do role, task, rules, format, examples, think step by step, and I repeat the task at the end just for good measure. And I often do all of these in my prompts. So here's an example. You're a hospitalist with 20 years of experience. You're an expert diagnostician. Follow best practices in deep reflective error. Make a differential diagnosis. Okay? So I defined a persona and expertise. Then task. So for a given medical syndrome, I want you to succinctly describe the clinical problem representation, and I want you to list the most common diagnoses. Okay? Rules. You must use structured thinking. Use the vitamins A, B, C, D, E, K mnemonic, and you must output in a certain format that I want. Okay? So these are the rules. Built in there is the format. So there it is. When I say format, this is what it looks like. And I gave this JSON is just a way that the computer likes to read it. They talk to themselves using that type of way. So I have a more extensive version, but this is the example of the vitamins A, B, C, D, E, K. And then I actually fill it in with an example. And I fill it in for someone who has a vestibular insufficiency or dizziness. Boom, there you go. So you can do one example. I often, if they're smaller examples, I give 3 or 4 examples in order to kind of show what the output I want it to be. And then I tell it to think step by step, and I tell it to do it, put it out. Okay. So that is the process that I do each time. So role, task, rules, format, examples, think step by step, repeat the task. So what does that actually look like? It looks like this. So you can see I used a lot of delimiters in it in order to kind of note each different section so that it kind of understands. I put an example, I put what it should be in it, and then how to do it. Okay. So that is one of my prompts. And then I give it a diagnosis or problem statement. So there's an interesting aspect. There's system prompts and user prompts. When you're just interacting with a ChatGPT just on the front end, you're often just doing a user prompt. You're just talking to it one by one. But on the back end, and Anthropic and a few others, you can actually set a system prompt or a custom prompt. And that prompt always gets fed in prior to your user prompt. So you can have it do some pretty interesting stuff by doing that, and basically do a shortcut. So I have one system prompt that does this, and I'm going to do it in real time. So I actually made it so it does that JSON, and then I have a code in there to show it in HTML. So I'm going to do this one right now for a rash for a girl and see what happens. So just look at this one. Again, I had it color coded, so the likelihood of right upper quadrant pain is a 5 out of 10. And now I'm having it go through and do that. So it's still thinking. It's probably going to take a while, so I may go off. But doing these prompts, I also do a few extra steps. Oh, here we go. Look at that. So it's likely an autoimmune, a type of rash. So on the flexure surfaces, atopy, right? So it tells us what it is. It's unlikely a T-cell lymphoma because of the age, but it's very likely to be an autoimmune eczema. Pretty cool, right? I do a lot of other tricks. I have in code, I put it in latex code. So I can make it do particular formats that I like. So this is an illness script. I have it so it has a driver diagram. I have quite a few examples of these. So I use ChatGPT. I give a prompt on the back end, a user prompt. I just give it a few words and it spits out all that information. So it actually is a shortcut for me. I can make a resume, a very, very, very fancy resume. And I'm now at the point where I'm actually using, and spending a lot of money doing it, using VS Code and Klein. There's Cursor, there's Windsurf, there's like 5 or 6 others, Bot. And I'm using an LLM in order to do some pretty fancy prompts. And then I use the agentic flow that I mentioned before to complete entire tasks. So not just one output, but have iterative improvements. So chain of thought is actually really helpful because you want to kind of understand what it's doing. So chain of thought is a tool that's where that step-by-step comes. That's actually also where the other models that are now coming into play that say that they have very long, they're thinking models, and they're actually going through and reasoning it out before they give information. And that's very helpful because you can understand, especially in medicine, how it's making errors or what's something that confuses it. I'll give you some interesting prompts that use a chain of thought. You don't have to hit the internet. You can actually download and run these directly on your computer. So I have like 15 models on my computer right now. So this is from Microsoft. It's called Phi 1, Phi 2, Phi 3, Phi 4. It's pretty good. It's pretty small and it runs okay. It can be done for like quick emails or things that aren't too complicated. And then again, it doesn't hit the internet. You don't give your data to anyone. So that is how I prompt. So here's the trick. The trick is actually within the different systems. For example, Anthropic, there's a prompt generator. So you can tell it to do something and it'll go through and actually make the prompt for you using all the tricks that I just said. Your role, what you're supposed to do, delimiters, context, information, rules, and then please be clear. So now you have this and you can use this prompt as an example and test it. And there's even an evaluation component in this. So it's not as many people have Claude, everyone has ChatGPT. The same thing exists in ChatGPT. So in OpenAI, there's a little button. If you go to your OpenAI and you go to Playground, OpenAI, and you go to this little star, it says generate. There's a little 3-star system that says generate. It'll pop up a box and you give your initial prompt, what you want it to say, and it'll go through and give you an optimized prompt that is quite good and a great starting point. So you can much more rapidly iterate and prompt at a much higher level. And all those custom GPTs that you see out there, a lot of them you can actually take and adapt. It is their information. Some of them have locked it down so you can't get in at all, and that's okay. But this is basically a prompt injection that tells them to read out the rules of the prompt. So this is a very interesting way to clone and then understand how people are making prompts, and you can recreate them and adapt them. Again, by doing this, I go through and I can make this with a one-shot prompt. Okay, I can make posters. Again, this is using the latex. I make curriculums. The big three, right now, Gemini is the best. The 2.5 Gemini is the best, but they literally trade places weekly. So Anthropic 3.7 was the best for a little while, and ChatGPT 4.1, and they're just going to be trading over and over again. And they cost billions of dollars to train. And you can test them out, all three of them, using the arena, the chatbot arena. So you can go through and check them side by side, and even models that aren't out yet, they put them there. So again, to reiterate, role, task, rules, output, tone, examples, and then I repeat it. I say, hey, what's your task again? So I have a prompt that does this. So evaluating your prompts. So be mindful when you're using these tools for medical purposes. Does it matter that the output is true? If yes, do you have the expertise to verify? And I want to underline that word, verify, that the output is accurate. And all of us practicing physicians do. We should go and cite our sources and understand our sources. Are you able and willing to take the full responsibility, legal, moral, for missed inaccuracies? And then you can potentially use different large language models. I was so worried. I actually didn't show a lot of my residents and students this because they were not able to safely assess the accuracy of the information. So if students are giving the assignment using ChatGPT, be sure they follow up with a discussion, a debrief, and clarify misconceptions, mistakes, and omissions. And the tools make those all the time. Iterative design works best. There's lots of different prompt engineering tools that actually also help you build those prompts automatically. And so you can get a lot faster. And using those IDEs and those are the tools, you can really do quite a lot. Be careful with bias. So the bias is we should have built-in systems that are regularly auditing and checking. This article was one that said for the different sociodemographics, 32 different biases, groups of populations, they found differential diagnosis just by changing out the different demographics. So this is a quite impactful paper. And this is one of the big ones that started all not for generative, but for predictive models. But it showed an 18% to 82% referral for higher level of care for African Americans versus Caucasians. And it was just absolutely awful for population health. So there's lots of issues with it. So studying it, understanding its intricacies, its quirk, the different models is very important. This is a fantastic cheat sheet that I found a while ago. So the key takeaways: role, task, rules, format, give examples, 2 to 4, 2 to 5, tell it to think step by step, and then repeat the task at the end for clarity. Thank you so much for your time.